Today we are going to see multiple correlation coefficient. So in previous year we have studied the correlation coefficient Rxy, that is correlation coefficient between variable x and y. We know its formula, and this is called as total correlation coefficient. Total correlation coefficient Rxy is called as total correlation coefficient. Here we are studying only two variables x and y, but in real life situation we have to deal with more than two variables. For example, suppose we want to estimate y, that is agricultural production. So agricultural production may depend on various factors such as x1, we can take it as soil type, x2 is moisture content, x3 is what type of fertilizer, etc. There are very many variables which can affect the production of agriculture, agricultural sector. So we have to study more than two variables in real life situation. So we have to study the multiple correlation coefficient. So basically multiple correlation coefficient is effect of x2 and x3, joint effect of x2 and x3 on variable x1. If we want to study the joint effect of all the variables remaining on the remaining variable x1, so it is called as a multiple correlation coefficient. This is denoted by R1.23. R1.23, that is a multiple correlation coefficient of x1 on x2 and x3. Multiple correlation coefficient of x1 on x2 and x3. Similarly, R2.13 is multiple correlation coefficient of x2 on x1 and x3. So here we study the joint effect of x2 and x3 on x1, then we have R1.23. So multiple correlation coefficient is nothing but simple correlation coefficient. So R1.23 is nothing but correlation coefficient between x1 and E1.23, where E1.23 is estimated value of x1. Estimated value of x1 can be estimated by using plane of regression of x1 on x2 and x3, which is given by b12.3 x2 plus b13.2 x3. So through the E1.23, that is estimated value of x1, we can have the joint effect of x2 and x3 on x1, we can study. So this is only, that is a simple correlation coefficient between x1 and E1.23. E1.23 is an estimated value of x2 and x3, which represents the joint effect of x2 and x3 on x1. So we will derive its expression R1.23. So R1.23 is covariance between x1 E1.23 divided by square root of variance of x1 into variance of E1.23. Now we have to find covariance of x1 and E1.23. Covariance of x1 E1.23. So this is given by 1 upon n summation x1 into E1.23. Since expected value of x1 is 0, so expected value of E1.23 is equal to expected value of b12.3 x2 plus b13.2 x3, and this is b12.3 expected value of x2 plus b13.2 expected value of x3, and these expectations of x2 and x3 are 0, so this is 0. So this expectation is 0, expected value of x1 is 0, so we have this. So 1 upon n summation x1 into b12.3 x2 plus b13.2 x3. So 1 upon n summation summation x1 x2 into b12 dot 3, this is constant, so outside the summation, plus b13 dot 2 divided by n summation x1 x3. So to deal with, we can go alternate way. Suppose x1 dot 23 is a residual of x1, which is given by x1 minus b12 dot 3 x2 minus b13 dot 2 x3. So x1 minus e1 dot 23, x1 dot 23. So e1 dot 23 can be also written as x1 minus x1 dot 23. So to going through this, we will simply use e1 dot 23 as x1 minus x1 dot 23. So we will go by this way, 1 upon n summation x1 minus e1 dot 23. So we will take 1 upon n summation x1 square minus 1 upon n x1 dot 23, x1 dot here x1 dot 23, 1 upon n summation x1 dot 23, 1 upon n summation x1 square minus 1 upon n summation, this can be written by using property of residual x1 dot 23, x1 dot 23. So ultimately what we have, so covariance between x1 e1 dot 23 is equal to 1 upon n summation x1 square minus 1 upon n summation x square 1 dot 23. So this is variance of x1 and this is variance of residual. Since expectation of residual is 0, so this formula represents variance of residual. So we have got this. Then we will go to variance of e1 dot 23. Variance of e1 dot 23. Variance of e1 dot 23, which is given by 1 upon n summation e square 1 dot 23 minus its expectation is 0. So 1 upon n summation x1 minus x1 dot 23 bracket square. So 1 upon n summation x1 square plus 1 upon n summation x square 1 dot 23 minus 2 upon n summation x1 dot 23. So this is 1 upon n summation x1 square plus 1 upon n summation x square 1 dot 23 minus 2 upon n. By using property of residual, we can write x1 as x1 dot 23 into x1 dot 23. So this is a minus 2 upon n, this is plus 1 upon n. So we have 1 upon n summation x1 square minus 1 upon n summation x square 1 dot 23, and this is equal to sigma 1 square and this is sigma square 1 dot 23. So we have got all these quantities. Now we replace it into our formula. So this is sigma 1 square 1 dot 23 divided by sigma 1 square into sigma 1 square minus sigma square 1 dot 23. So this is sigma square 1 dot 23, this is square root. So we have sigma 1 square 1 dot 23 divided by sigma 1 square, and this is equal to 1 minus sigma square 1 dot 23 divided by sigma 1 square. This is the expression for R1 dot 23. Now we have variance of residual. We have calculated it as variance of x1 dot 23, which is nothing but sigma square 1 dot 23, which is equal to sigma 1 square into determinant of R divided by R11. We will replace this value in this equation. So here 1 minus sigma 1 square determinant of R divided by R11 sigma 1 square. This is 1 minus determinant of R divided by R11. So R12 dot 3 is nothing but square root of 1 minus determinant of R divided by R11. This is the expression for R1 dot 23 in terms of correlation coefficient matrix. Now we will solve this in terms of total correlation coefficient R12, R13, R23. So this is equal to R11 minus determinant of R divided by R11. So this is R11 minus determinant of R is 1 minus R12 square minus R13 square minus R23 square minus 9 plus 212 R13 R23 divided by R11 is 1 minus R23 square. So this is equal to 1 minus R23 square minus 1 plus R12 square plus R13 square plus R23 square minus 2 times R12, R13, R23 divided by 1 minus R23 square. So this is equal to R23 square get cancelled, 1 get cancelled. So remaining is R12 square plus R13 square minus 2 times R12, R23, R13 divided by 1 minus R23 square. This is the expression in terms of correlation coefficient, total correlation coefficient of R1.23. So here 1 get cancelled and R23 get cancelled. Then we have got this expression. So similarly R2.13 is equal to square root of R12 square plus R23 square minus 2 times R12, R13, R23 divided by 1 minus R13 square. So this is the expression for R2.13. Similarly, we can obtain R3.12. So this is an expression for multiple correlation coefficient. R1.23 is nothing but joint effect of x2, x3 on x1. So dot comes after 1, and this is a represent the joint effect of two variables on single variable. Now what will be the interpretation of R1.23 is equal to 1? If R1.23 is equal to 1, then R1.23 is equal to 1, which gives 1 minus determinant of R divided by R11 is equal to 1. So square on both sides. We have 1 minus determinant of R divided by R11 is equal to 1, which gives us determinant of R divided by R11 is equal to 0, implies determinant of R is equal to 0. And determinant of R is equal to 0, it means all three regression plane coincides. So this is a interpretation of R1.23 is equal to 1. We have another interpretation for this. We know that R1.23 can be represented in terms of sigma square 1.23. So sigma square 1 minus sigma square 1.23 divided by sigma 1 square, and so this is expression for what is the expression for R1.23? R1.23 is given by sigma square 1.23. This is expression for R1.23. So if R is equal to 1, this is 1 minus sigma square 1.23 divided by, this is 1 minus sigma square 1.23 divided by sigma 1 square. We have to divide sigma 1 square separately. then square so put r1 dot 23 is equal to 1 is equal to 1 minus sigma square 1 dot 23 divided by sigma 1 square on both sides. We have 1 is equal to 1 minus sigma square 1 dot 23 is equal divided by sigma 1 square. 1 get cancelled, so sigma square 1 dot 23 is equal to 0. That is variance of x1 dot 23 is equal to 0. So residual variance is 0. That means we have perfect association. We have perfect association between x1 on x2 and x3. It means for given value of x2 and x3 we can exact find the value of x1 that matches, so where residual become 0. This is another interpretation of multiple correlation coefficient when it is equal to 1. Now we will go to another interpretation when r1 dot 23 is equal to 0. When r1 dot 23 is equal to 0, r1 dot 23 is equal to 0 means what we have? This is nothing but a correlation between x1 and e1 dot 23 is equal to 0. That means the correlation between x1 and other two variables is 0. That is x1 is uncorrelated with x2 and x3. That means the plane of regression, of x1 on x2 and x3 will unable to throw a light on relation of x1 on x2 and x3. So linear plane of regression is not useful in this case if r1 dot 23 is 0. That is the relation between x1 on x2 and x3 is 0. That is x1 is uncorrelated with x2, also it is uncorrelated with x3. This is an interpretation of r1 dot 23 is equal to 0. So this is the interpretations of r1 dot 23. This can be considered as properties of multiple correlation coefficient. Then we have another thing. We have Ri dot jk, that is general multiple correlation coefficient, is greater than Rij into Rik, or it is greater than Rij absolute and Rjk absolute. So why we take absolute, we will see what is relation. So why we take absolute, we will give answer here. We know that r square 1 dot 23 is 1 minus sigma square 1 dot 23 divided by sigma 1 square, and which is also equal to 1 minus determinant of r divided by r11. So by equating this, what we have, r square 1 dot 23 is equal to 1 minus sigma square 1 dot 23 divided by sigma 1 square. So sigma square 1 dot 23 divided by sigma 1 square, 1 minus r square 1 dot 23. So sigma square 1 dot 23 is nothing but sigma 1 square into 1 minus r square 1 dot 23. This is our expression, and from this expression we can see that this multiplier is positive. So sigma square 1 dot 23 is less than or equal to sigma 1 square. Sigma square 1 dot 23 is less than sigma 1 square. By noting this, we can see r1 dot 23 is nothing but 1 minus sigma 1 square minus sigma square 1.23 divided by sigma 1 square. This is a positive since it is variance, and this difference is also positive since sigma 1 square is greater than sigma square 1.23. So this is also positive, it is difference. So positive positive, so this R1.23 is a positive. So R1.23 is positive. Since its sign depends on this sigma 1 square minus sigma square 1.23. This is nothing but this is equivalent to covariance of x1 and E1.23. This is divided by variance of x1 into variance of E1.23. So this covariance is positive. Covariance is positive. Covariance is sigma 1 square minus sigma square 1.23. So this difference is positive. So R1.23 is a positive. So we have got first condition, R1.23 is a positive. Then this is first condition. But R1.23 is a correlation coefficient. This is a correlation coefficient between x1 and E1.23. As it is correlation, so it lies between -1 to +1. This we got second condition. By combining equation 1 and 2, what we have, R1.23 is always positive and it is greater than 0 but less than or equal to 1. So R1.23 is lies between 0 to 1. It never takes negative value, but our general correlation coefficient can take negative value. So this way we have, and multiple correlation coefficient R1.23 is greater than or equal to correlation between x1 and a plus bx2 plus cx3. So what it means, R12.3 gives maximum correlation for any other linear combination of x1 with x2 and x3. So this gives the maximum correlation, measures the maximum correlation between x1 and any other combination of x2 and x3. So this is one of the property of multiple correlation coefficient. Thank you. We will stop here. Thank you.